Well, hello, geometry. I hope that you've seen on Google Classroom, Mr. Field Math Assignments by Class document. Uh, so here you are, the green section here, and this is the second week of January. So we're going to do angles of depression and elevation. Your IXL is right here. And we're also going to look at 2-2. Yeah, not 2-3. So we're gonna take a look back at logic. So you can see there is, I mean, isn't this great? You know, your IXL is there for the rest of the year. I went ahead and figured it out. I don't know. I don't know what got into me. And then the other thing is, yeah, so we got our section that we're going to cover this week. We got the IXL, and then on the bottom is an interlinked, or at least spaced section from the past that we're going to revisit, because we know that when you revisit things after some times went by, you forgot it, and then you remember it again and practice it again, and that is how you truly learn, so that you'll remember. Okay, so a lot of things in geometry are interleaved and come back up anyway, but there's some things that that we do need to revisit. So that should be fun. So this week, let me just scroll back down. This week is angles of depression and elevation. Your IXL is I, 2, 4, 7, 10, and 13. And then we're also going to look at 2-2 logic. All right, so let's start out with, you ready to take some notes? Angles of depression and elevation. All right, so make sure that you have this this document right here. Hold on 1 second. Sorry about that. All right, so this diagram is a very important diagram, because you need to know when they say angle of depression or elevation, what angle exactly they're talking about in a triangle, and it's a little bit easy to get it messed up. All right, so angle of elevation, that's if you're a guy here and you're looking up into the sky, the angle with respect to, you know, the horizontal that you have to look up is called the angle of elevation. The angle of depression would be someone up here and then they're looking down, right? So you can see they actually are like alternate interior angles if you think of this big rectangle here. All right, so the angle of elevation triangle is, I guess, that normal, and then the angle of depression triangle is the same triangle upside down. All right, so when we're trying to draw a picture, oh hey, I just said that. When we're trying to draw a picture, we can keep that in mind. All right, so let's try to draw a picture. The crossbar of a goalpost is 10 feet high. Okay, the crossbar. I knew that. Yeah, so there's the goalpost, 10 feet high. If a field goal attempt is made 25 yards from the base of the goalpost, all right, so somewhere over here, and that's 25 yards. Uh-oh. 10 feet, yards. We'll deal with that. Okay. It clears the goal by 1 foot. Okay, so it goes up here, and so that makes 11 feet. right, for the ball's height in the air, what is the smallest angle of elevation with which the ball could have been kicked? All right. So first of all, 25 feet, we know that there's 3 yards in, I mean, 3 feet, 3 feet in 1 yard. So let's multiply that. 25 times 3 is 75 feet. All right, so that's 75 feet. So we get our units squared away. So our triangle is, oh, and also this is interesting. We want to know the smallest angle. So we didn't talk about that last week, but it won't be too much of a stretch here from what we did. So our triangle, just one more time, is this triangle 11, 25, and this is what we want to find, this angle. And the symbol that I've drawn looks like a little egg with a little squiggle in it, and that is the Greek letter theta. Theta. All right, so in math, we use x a lot for a variable. Sometimes I put an x in there, but a lot of times when you are looking for an angle, mathematicians use theta. So let me introduce you to theta. You know, you already know the Greek letter pi. You know that pi symbol is the Greek letter for P. And so theta is the Greek letter for T, I think, even though it looks like a O. All right, baby's crying. I'll be right. So now that we have the triangle right here, and we want to know theta here, what we got to do is we got to figure out the trig ratio. So we have the opposite side and we have the adjacent side. So which ratio connects opposite and adjacent? That would be tangent. So opposite is 11 over adjacent 25. And so when we don't have the angle measure, what we do is we use inverse trig. Which is really easy because you just use a calculator. So you know how the inverse of different things is what we use. You know, just for example, this is not related, but if I wanted to solve for x, I would divide by 25 on both sides, and I would get 11/25. That's because multiplication and division are inverses of each other. Well, you can't divide both sides by tangent because we're not multiplying tangent and theta together. This is a new operation, trigonometry. And anyway, so what we do is we take the tan inverse of both sides, and that undoes tangent. And then on the other side, we have tan inverse of 11/25. Okay, so now we're going to go to Desmos. We're going to make sure we're in degree mode, and we're just going to type tan raised to the negative first power, 11/25. That's it. That's all you got to do. So the angle measure is 23.749, 23.75 degrees. Can I put that? Oh wow, look, I can put that right in the book there. All right. Only I don't want to put it on top of the, let's make that a little bit smaller. Okay. So there we go. Now let's move on. Okay. Next one. A lifeguard is watching a beach from the line of sight 6 feet above the ground. She sees a swimmer at an angle of depression 8 degrees. How far away is the tower from the swimmer? All right, so this time we're going to find side measure, right? And we have the degree measure, so there's no inverse trig there. What else do we know? We know 6 feet. The lifeguard is watching a beach from a line of sight 6 feet above the ground. So there's a 6 there. And then, all right, so now I'm going to set up a ratio. And what sides of the right triangle do we have? We have the opposite side, and we want to know the hypotenuse. So what trig ratio connects the opposite and the hypotenuse? That would be the sine. So sine of 8 degrees equals opposite over hypotenuse. And so I just put that over 1 and I cross multiply. So 6 times 1 is 6. And sine of 8 times x is x sine 8. Now in this case, we are multiplying x and sine 8 together. So I will be dividing both sides by the sine of 8. And so x equals 6 over the sine 8. Let's find out what that is. 6 divided by the sine of 8, 43.11 equals approximately 43.11. And what is that? Feet. So that is how far a lifeguard is. Pretty cool. So we can use trig, to measure far distances just by knowing one distance and an angle. And the angle is super easy to calculate. And if you know one distance, then you can get some distances that you could never measure with a measuring tape or anything like that. Okay, so now it gets a little tricky when we have two triangles, but we're just going to end up doing some subtraction, right? So you can read the example there about tree removal. But here we're going to do skyscrapers. Everybody ready? 2 buildings are sited from atop a 200-meter skyscraper. Building A is located at 35-degree angle of depression, while building B is sited at a 36-degree angle of depression. How far apart are the 2 buildings? Wow, that's cool. Okay, so 200-meter skyscraper. Wow, it's a tall one. And building A is sited at an angle of depression 35 degrees. Okay. So there's one building. Put a big A on there. Building B is 36. So that's 36 is going to be a bigger angle. So building B must be like right here. 36 degrees bigger than 35. Okay, so now we got our triangles and we got our distance. How far apart are the 2 buildings? So what we can do is we can find these sides right here, and then we'll just subtract them. So let me draw up here. I'll draw. Oh, but here, see, here's the tricky thing. So we got the 200. And so we're just going to say, okay, all right. I guess we might need to say, that, well, this could be a little tricky because is the 200 going to be the full side, or is it going to be from the top of the building? Right, this is where it gets a little tricky. So let's just consider that this full triangle is going to be like that. This triangle is going to be like that. So anyway, we end up with, I'm going to draw it nicer. So we get the 235, and then we get another triangle. Whoops. $36, 200. And so we want to calculate these two side lengths, and then we want to subtract them. And that will be the distance between our buildings. Okay, because X and Y are the total lengths from our skyscraper to the building. So in both cases, what trig ratio are we going to use? In both cases, we don't care about the hypotenuse. We have the opposite and adjacent, so they're both tangent. Okay, so let's calculate some tangents. So tan 35 equals opposite over adjacent, 200 over x. And so we're going to end up 200 equals x tan 35, x equals 200 divided by tan 35. And so without even doing it, I know that y, since it's like the same thing, y is going to be 200 tan 36. So let's figure out x and y. 200 divided by tan 35 is 285.63. 285, so x is 285.63. And then change that to 36. How much does that actually change? Wow, 275.28. All right, and then so we just subtract 285.63 minus 275.28. Okay, 0.63 minus 275 point what? 0.28. 10.35. So according to our calculations, 10.35 meters. And if we had to adjust because we do the right triangles, at least we have the right idea. It wouldn't be too bad. Okay, so that is that. But now let me pause and open up our 2-2 logic section. Let's take a look back at that. All right, so I didn't pick every section that we do to go back to, but I picked ones that either, it's been a while, you'll forget them, or I just know that they're really important. So statements, truth value, negations, compound statements, conjunctions, disjunctions are very important. in math and logic. So let's just go back to that for a second. So statements are sentences that are either true or false. Negation of a statement has the opposite meaning and the opposite truth value, right? And then compound statements are two statements put together. You can put the two statements together by the word and or the word or. When you connect them with the word and, it's called a conjunction. When you connect them with the word or, it's called a disjunction. All right. If they're and, then they both have to be true for the compound statement to be true. Or only one of them has to be true for the compound statement to be true. And let us not forget truth tables. Let me open this with Cami. How many of you remember truth tables? Okay. So let's do a truth table. P and Q. So this is the and remember, because it looks like, yeah, it looks like an N. Okay, so remember we go like this, T, T, F, F, and then Q, we just rotate, and then P and Q is only going to be true when they're both true. So that's T and then 3 F's. Not P and not R. Oh, okay. So not P and not R. So we'll still start out same way, rotating, and then not P and not R. So now we're going to have to make not P, not R, then not P and not R. Okay, so not P is going to be false, false, true, true. Not R is going to be false, true, false, true, just switching the truth values of those two columns. And then and is only going to be true when both of these columns have a T. And they both have a T in the last row. That's the only time. And so there you go. That's the truth table for not P and not R. Okay, or now that truth table is just going to be true when there's at least one T, right? So we can do that. Was I not even supposed to do a truth table for that? I just went ahead. Oh, you're supposed to write it. Well, you know, so just write the compound statement. For P and Q, okay. The figure is a triangle and the figure has two congruent sides. Oh, find its truth value. The figure is a triangle and the figure has two congruent sides. That is that true? That looks true. Looks like it's a triangle with two congruent sides. Okay. So, okay. So we got negations, conjunctions, disjunctions, truth tables, and we kind of skipped Venn diagrams. All right, so that's a good little review of truth tables and a little bit of the basics of logic now. Next week, we will do, we're going to do 2 sections from chapter 8 and a review of conditional statements. But for this week, go ahead and practice those practice problems in section 8.5 and also do the IXL, I2, 4, 7, 10, and 13. All right, bye everybody. See you in class.